All right, let's get started.
All right, let's go. So good morning, everybody. I'm Vicki Harp, and
My name is Vin Yu.
and we're both program managers on the SQL Server team here at Microsoft. And we're here today to talk about DevOps with SQL Server on Linux plus containers. And so we're pretty excited to talk to you about some of the big changes that have happened in SQL Server 2017 and moving forward with support of these more contemporary practices in DevOps and containerization. So one of the big changes with SQL Server 2017 is SQL Server is now able to run on your platform of choice. So we've been running on Windows for the whole history of SQL Server. Now we're able to run on Linux, multiple flavors of it, which gives us the opportunity as well to run in a containerized environment as well as on Kubernetes. And so today's presentation is mostly going to focus on those Linux and containerized utilities for SQL Server 2017. So with this, we have brought in the new functionality of SQL Server to run on that environment, which means that we're going to have to start helping the SQL Server world understand the new DevOps paradigms that we can bring into a SQL Server world, and as well as the new tooling that we're going to provide to help people move in that direction. We know that a lot of people who are SQL Server experts have a deep Windows knowledge, so we're going to help people transition over into the Linux world. And then people coming from more of a Linux background might not be as familiar with SQL Server, and we'd like to help them be onboarded as well. So just to start things off, we're going to start with a demo and show you what SQL Server on containers is all about. So I think a lot of people might have heard about this or maybe seen little press releases and things, but if you haven't seen this yet, this is how simple it is.
So we're just going to start here with our prompt. Oops, server. And the first thing I'm going to do, so I'm on a Mac machine and I'm a developer. I would like to get started with a local instance of SQL Server. I don't want to have to go somewhere else, either go to my admin or have to go or set up an entire VM to get started. So it is as easy as just doing a Docker pull. So our images are on Docker Hub. So it looks like I already have the latest image. So the next thing I'm going to do is just get this started, just running. So I started this with a Docker run. And it only requires at minimum 2 environment variables. One of them is to keep our lawyer friends happy. So we do have that set the EULA here. And by default, this is running Developer Edition. If you want to choose to run another edition of SQL Server in containers, there's an additional environment parameter flag which you could specify either standard, enterprise, or any other SQL Server edition. And the second required parameter is to set our password. Right. So with that, let's just get connected to it really quick. So here I specified localhost, so I already have this connection saved. And who here has seen SQL Ops Studio? Most of the people, well, that's the majority of the people in the room. So Ops Studio is our new cross-platform GUI tool that we introduced last fall. And this allows us to connect to SQL Server from Linux, Mac, or Windows.
He is running on a Mac.
I am running on a Mac.
This is the real world. This is a Microsoft
So
conference.
you can see that inside our container, we are running Linux Ubuntu, which is the flavor of the image which is there. And from this point on, it is the same SQL Server as it is on Windows. The same engine, same capabilities that you would expect on Windows as well. All right.
All right. So why containers? So one of the things that we really want to help to understand is that SQL Server is a component of your application. It's not necessarily just a server. I mean, in the name it says SQL Server, but we've moved on, and the way that things work now, you should be considering SQL Server to be more of a component of your application. It's the component that provides the database functionality, but the relationship in the way that you manage it can be more like the other components of your application. And so when you think about it, traditionally maybe people think about having an application with backing database, and they think of SQL Server as being one with the database and their application as being an entirely separate thing. But when you think about other dependencies that you have in your environment, you probably do think about those as components that you bring along and that are separately versioned. And what we're saying is that SQL Server is kind of the same. The engine that supports your data is actually a component. So whenever you have a version 1 of your application, a lot of times it comes with other versions of other dependencies. So your dependency from an open source project, et cetera, might be a version 2.3, and in this case we have version 2017 RTM of SQL Server. All of these components are present. When you go on to your version 1.5, you may have also separately versioned your other components. In this case, dependency foo has gone to version 3, and SQL Server has gone to version 2017 SP1. You might also be versioning these things independently of your application code. So you might be saying, I'm going to push a new version of SQL Server, I'm going to push a new version of this library, but I'm not necessarily going to update my app code, or vice versa. So those SQL Server components that you have probably exist in a lot of places in your environment. You probably have SQL servers in production, your integration and staging, user acceptance, shared dev, local dev, all these different places have SQL servers. And traditionally, if you're treating these as each being separate production style environments that you have to maintain, that's a lot of extra work. And there's a lot of data flows that go between those, both of data and then just of updates. So if you're treating SQL Server like a monolith and a service and a server in each of these environments, you have to do the updates on all of those. You have to keep the data consistent among all of those. And that's a lot of work, and it causes a lot of pain. And frankly, among developers, it causes SQL Server to be pushed down in their mindset. There's like, all right, SQL Server is kind of its own special snowflake that I don't really know that much about. So until it's in production, we don't really trust what's going on with it. My local dev copy, it acts a little weird, but it probably won't do that when it gets to integration. In integration, that's not really very representative, but it probably won't be that way in production. And so you have a little bit more of a lackadaisical approach toward your data than you might with other components. If you had that sort of behavior with another library, an open source library, where your developers weren't pulling it down to their local machine for testing, you would probably view that as a red flag. But we've had that situation going on with SQL Server for a long time, and partly that's because of the difficulty of keeping everything maintained and people's skill sets not really being aligned with them running SQL Server in their local environment. So component management in general is simplified through containers. I've been using the term Lego blocks a lot, where it's almost like you create these Lego blocks and they have all of the different components already set up. I'm sure a lot of you remember kind of the bad old days whenever setting up a dev environment involved a whole lot of installing special executables and setting up special environment variables, and kind of you had to breathe just so, and if you were setting up a build machine, maybe you'd forgotten how that works and you had to go find the one person on the team who remembers, or you had to take a special VM just for the ability to do a build. And all of that is true amongst, throughout the development environment, but it's also true with SQL Server. And component management, in general, is simplified through containers, which is why in the DevOps world, containerization is taking off, and especially in comparison to virtual machines. And we'd like to make sure that SQL Server doesn't get left behind, and that as you're working on these practices in your own practices, that you don't forget that SQL Server can fit into it. So I said, as compared to VMs, and just as a quick level set for anybody who is coming in, I know it's day 3 of build, and most of you have probably heard about containers, but just to be clear, a container is not just a VM. If you think about the structure of a VM, you've got your hardware infrastructure and a hypervisor that's running on top of it, and then each of your virtual machines is composed of an OS, its libraries, and your app. So when you're talking about a hypervisor situation, you might have multiple different OSs running on that same hardware, which is a nice thing. It gives you a lot of flexibility, but it means that these VMs are very large. And that makes them cumbersome to move around. There's a lot of technology, and especially third-party value adds that have been created for virtual machines because it's getting to be a relatively mature technology now. But it is still the fact that these VMs are large. Most of the time they're stateful. A lot of times you have to treat them very carefully. A container is not that. With a container, you have an infrastructure with a host OS, and then your containerization technology, in this case Docker, is running on top of that OS. And then the containers only are comprised of your app and your libraries. Basically, they all share the same OS in this structure, but they're much, much smaller. And so by best practice, most of the time these are treated as immutable, their application code and the underlying libraries. And so whenever you are able to deploy these, you can do them much faster. You could see whenever he pulled down that SQL Server image, he already had it, so you weren't able to really see how fast it pulls down, but it's actually very, very small compared to even downloading the MSI installer for Windows. And that's because it really just has the minimum amount of code and binaries necessary to make it run. So containers simplify development and deployment because you can separately deploy these containers as separate components into your different environments. So in the case of SQL Server, you can separate your logical components of your data estate into the different actions. So you can treat your SQL Server binaries and send them out as containers. The great example of this is if you're going to version SQL Server. With containers, you don't have to do an in-place upgrade. You don't have to take an outage while bits are being moved around on disk. You actually just take a new container that has the newest version of the SQL Server engine, put it up there, pull down the old one, and that's it. You know, it's an instant changeover. With data updates, you can treat those separately. Even though most of the time people talk about containers being immutable, you can have attached storage, persisted storage. And so the data updates that you make, if you use scripts, if you use anything that's kind of, I guess, structured, then you can deploy that structure across dev, test, and production. The other thing you can do is, let's say you wanted to have small test data sets, you could actually put those into containers so that they could be pulled down for someone for testing purposes. You could push up a set of, contrived data in order to facilitate testing of particular data sets that you don't necessarily have to put the entire database up there. You can just put little container versions of it. And the same with schema updates. You can, we're going to show this a little bit later, how you can push out schema updates and have them maintain the same across your dev, test, and production environments. Now, like I said, containers are, they use the underlying operating system, which introduces a cross-platform data scenario for SQL Server. So, it's a chicken and egg problem. Did we say SQL Server should run on Linux first, or did we say that SQL Server should run on containers and therefore it should run on Linux? Basically those two came together, but the fact is that even though Windows containers are coming, and they do exist and they're coming for Kubernetes, really the most conventional use of containers is using the Linux environment. Now we know that a lot of people at this conference in particular are Windows developers, but with .NET Core and with a lot of the other technologies inside Microsoft, we're really embracing Linux, and SQL Server is no exception. So that means that for Windows developers and for Windows DBAs, there's going to be a learning curve involved in learning how things work within SQL Server on a Linux environment. But SQL Server's own surface area is predominantly the same. There's a little bit of changes, and where those changes exist, we're actually working on simplifying them or reducing them. So for example, right now you're using SQL authentication rather than Windows integrated authentication, but that's something we're working on. And some of the individual enterprise features might not work quite yet, but you'd be really surprised at the degree to which the surface area is the same. The T-SQL language operates in the same way, and you have your code run. When it gets to the operational components, I actually think that there's more of a learning curve to learning how to do things with a container mindset than there is to learn to do things with a Linux mindset. You might have to go in and maybe learn some of the individual details about how to make a directory or how to change directories, etc. But to my mind, that's really no different. I'm actually this week changing over from iPhone to Android, and so it's like there's a lot of things where I'm, thank you, and there's a lot of things where I'm reaching for what I'm, literally reaching for what I'm used to, and I'm not finding it there, and that can be a little frustrating, but I have faith in myself that I can figure this out, and I have faith in you guys, if you're coming to Linux and you've never worked with it before, I believe you can figure it out. I don't think that, you might find some frustration, but you're going to get there. And it's going to be good for everybody, and it's going to help us all to understand that SQL Server is a component. It's not just something that's part of Windows. It's not just something that you use in a Windows environment. This is also important as we're moving to more cloud-focused deployments. Whenever you're talking about containers, that's something that has a very hybrid story, and so you're probably already having to learn how to deal with hybrid or pure cloud scenarios. You're learning new tools. This is one of the things. So in terms of cross-platform tooling, the SQL Server team is working really hard to make sure that you have the rich tools available for your cross-platform scenarios as you do for Windows. So SSMS has been around, is well loved, is highly functional. It is a Windows tool. Now you can use SSMS from Windows to connect to a SQL Server on a container or on Linux. That's no problem. But if your actual dev environment is, say, on a Mac, or if you're working within a command line environment on Linux, you're going to need some additional tools. So SQL Command and BCP, those were GA'd with SQL Server 2017, and they're complete and they work just fine. So that's the traditional tools that you might be used to. And that's a nice thing, because if you have existing scripts and deployment scripts, etc., that are based on SQL CMD, it's going to still work just the same as it did. SQL Operations Studio, you saw a glimpse of just a moment ago. It's a kind of Visual Studio Code similar environment for doing SQL Server development and operations and management, in a cross-platform environment. So that's actually in preview right now, and so we're really excited. It's happy to take your feedback on it. We have GitHub repo. We take that very seriously. Whenever you submit feature requests, when you submit bug reports, there is a whole group of people who look at that immediately, and we talk about it, on a daily basis. So that's something that we've got out there, and it's going to be GAing, sometime this year. MS SQL CLI is another command line tool, and this is an interactive command line tool. If you've ever tried to do SQL command from the just doing interactive coding from SQL command in the command line, you probably know that it hurts a little bit. There's a lot of places where you're having to tab away to find the name of an object, etc. MS SQL CLI has IntelliSense and autocomplete, and it does some really nice work with scrolling left and right on large data set, so you don't just have like it was over so many characters and so it's just wrapping and wrapping and you can't read anything. It actually creates columns. You can do left and right, up and down scrolling. It's very nice. And so
autocomplete.
Autocomplete.
Like you have to just get that sense that SQL CMD, you're gonna, like you said, you have to alt-tab to remember the object name, and if you misspelled it, you're just gonna get an error returned.
Right.
There's autocomplete.
Yes, it's a far better experience, and so that's in preview right now too. And then SQL package, which for those of you who use SSDT and DACFX, we're incredibly close to having the preview out for that, for you to be able to use SQL package to push your changes out, both in a Windows environment and in a Linux environment. So we're working on those. This is what we've got now. I'm sure we're going to be moving on to even more. It's the new mandate. We need to make it just as easy for you to do this in a hybrid cloud or a container environment as you do for your Windows environments. So I've been talking a lot about containers, and then I want to talk a little bit about container orchestration. So I want you to imagine, we're in a production environment. I think we have 900 different containers. Hey, Vin, you want to go start them all?
Yeah, okay, don't worry about it. I'll just do Docker on each one of them independently. Right?
And then what if one of them goes down? How do you know? And what are you going to do about it? So that's where container orchestration comes in. In a production environment, you're probably going to be using one of the tools that actually keeps track of your containers and keeps them up and running and does the care and feeding for you. The one we're going to be talking about today is Kubernetes. And I have a little clip here about what Kubernetes describes itself as, which is it's a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So going into the entire structure of Kubernetes is beyond kind of the mandate of this presentation, but I'll kind of give you a sense of what SQL Server looks like when it's running on Kubernetes. So Kubernetes has this notion of services and nodes, and the nodes are basically like computers. And then in this environment, what we've got is a persisted volume that has all the database files, so your actual master database, all of the different database MDF and LDF files. And then you have the SQL Server engine running in a pod on one of these nodes. So in the case that that node goes down, either by you taking an action like you're wanting to upgrade it, or you killed it, or something went wrong, Kubernetes will automatically pull it up again. This is basically failover clustering that you get for free. And so the thing to remember here, if you've got nothing else about this on how do you manage SQL Server in a Kubernetes environment, it's basically separate your compute and your storage. If you're talking about your compute being immutable, containers that you can kill at a moment's notice, just make sure that what you've got running in that container is a SQL Server execution environment. So you've got the query processing, you've got the query optimizer, you've got all of that wonderful functionality, but ultimately it's writing through into the storage. SQL Server itself, once it pulls data up from storage, it does a really good job of doing a lot of its work in memory. And so you don't necessarily have the amount of contention on storage that you might think. Depends on your workload. This is a large topic. But whenever SQL Server goes down and is brought back up on another node, it's going to rehydrate its own memory and go on. It's made to do that. That's one of the reasons you use a transactional engine, is so that it can recover from a crash. So even if it goes down in an uncontrolled fashion, it'll do transaction roll back and roll forward just like it would in any other crash situation. So let's show what that looks like.
So just to show that exact same diagram that Vicky just had up in the presentation, here I have my local environment connected to Kubernetes environment in Azure, and I have SQL Server deployed there. So here is just my Kubernetes dashboard. that has the deployments, the pods, as described, Vicky just described. So let's just start with nodes. So here I have a 3-node cluster. This is 3 separate VMs running in Azure, which my Kubernetes is, which supports my Kubernetes environment. And to look at, we'll start with the deployments. The deployments represent the state in which I want my SQL Server running. So here I have one pod that's currently running out of a defined, the desirable state of one pod. Right. So here I have, that's not what I'm looking for. Yep. 1 second here really quick. Let's connect to the wrong environment. So here I have my one SQL Server deployment running here that's running on this one pod. So this is SQL Server running a container in a pod on one of the VMs. All right. And this is backed, so because this is running as a stateful service, right? By default, containers, the data will disappear as ephemeral. So the data will just disappear. So how do I back that up? I have here persistent volumes which stick around even if the container or pod dies, right? So when Vicky said, hey, if the container dies or the machine dies, the volume will stick around. And this is using Azure Disks to back that up, right? In here, I have a service that has an external endpoint and internal endpoint. Internal endpoints are which other services or applications can talk to my SQL Server. In my demo environment here, I have an external endpoint, so I could connect to it from the internet as well, from the web. But typically, you would not be exposing your database endpoint out in the public. You would just have it accessible within your environment, which your apps can only present. Right.
Which is actually, that's an important thing too. I'd say that in some environments, even just traditional VM environments, it gets confusing, and so people do open those external endpoints even though they shouldn't. And that's something that I think is easier to do right in Kubernetes because you have to kind of take an extra step to make it public.
Mm-hmm. Yeah, so Vicky just mentioned, hey, what happens if the pod dies, right? So let's just go ahead and kill that pod right now. Whoops, this is the logs. So let's go here. And I'm going to delete this pod.
Are you sure?
I'm pretty sure. I don't know, let's just simulate something that went wrong. So immediately, we could see that another pod was sprung up, right? So here we can see that, hey, look, this running pod that's on the bottom, this is the one we just killed. And here it just has some caching. The caching just let that, the Kubernetes dashboard just hasn't deleted that one row yet. But right now we have another container being created on the fly. So depending on how it's recreated, so if the same pod is being created on the same node, it happens within 5 to 30 seconds. But if you have to shift, if Kubernetes is deploying your pod on a completely different node, it's going to take a little bit of time because it has to detach and attach that same volume that backs up that SQL Server, right? So let's just take a refresh to see. Okay, so it's probably going to it takes as much as from what I see in 3 minutes. We'll just move on with this, and maybe we'll come revisit this in a bit to see if it has been, if it's up later.
Yes, all right. So containers are also helpful to simplify the developer onboarding experience. I mentioned earlier about the bad old days of all of the different, environment variables, et cetera. And so he showed you how easy it is to pull down just a copy of SQL Server and run it. That's not really a good example, though, because how often do you have somebody come in and they get their badge and they get signed on and they get their machine, and then you say, hey, install SQL Server and then write an entirely new application. Odds are you're onboarding them into a development environment with certain practices already in place. So if you think about, like I said, the bad old days, a lot of times what people would do is they would set up a single dev server and say, hey, everybody, pull down your code, set up your dev environment in Visual Studio, and then use this single dev server for everybody so that we're not having to worry about maintaining all of your different SQL Server developer editions. Or maybe you had kind of rogue instances that people were installing locally. But the thing is, a shared dev server is its own production resource, and that's something that organizations often get wrong. If the dev environment goes down, okay, maybe that's not an outage to your customers, but that's an outage to 100 developers, and that's a big cost to your organization. Or if somebody is doing something and they make a mistake just in the course of development, they drop a table, something like that, now everybody else is blocked from doing work. That's a costly mistake, and that's the sort of thing that will make developers unwilling to do experimentation. They're unwilling to try new indexes. They're unwilling to try different data patterns. They need to make something, like let's make this table really big and see what happens. What happens is it brings down the app, but they can't troubleshoot that because everybody else needs to get back up. And so everybody gets a lot more cautious, and next thing you know, they're not even wanting to learn T-SQL. They just figure, this is something that I'm going to push off to an operations team to take care of for me. And that's really something that as a developer has always perplexed me, in that developers often will get really passionate about the latest JavaScript frameworks, and they'll get really passionate about the internals of .NET. And then when you get to SQL Server, they don't even really want to know T-SQL. They want to step way back from it. And it's kind of this interesting self-protection mechanism, I think, because it's something that after you've slapped, especially a junior developer, slapped them on the hand a few times for having messed up or for having experimented in the wrong way, they're going to take it that SQL Server is not something for them. That's not something for a developer to know about. It's something that belongs to someone else. And the other thing is that, in some environments, what they do instead is they say, let's have everybody have their own VMs. But that is a time-consuming process. It uses a lot of resources on the developer's machine, or they have to have another machine at their desk that has it. And let's be real, people don't like how long it takes. They're not going to want to refresh that environment. They're going to forget about it. It's going to get in a weird state, and they're just going to say, never mind, I'm going to use the shared server, and you're back to kind of the same old thing. So with containers, you're able to create an experience that makes it more like the code experience, where I'm going to pull down my code, I'm going to pull down my data environment as well, and I'm going to be able to do my local experimentation and my local learning without stepping on other people's toes.
So as Vicky said, if you just treat the database like your other libraries and dependencies, that's the way we should be thinking about SQL Server and containers for your development environment. So here on my right, I have my other terminal here, and I have my ASP.NET application that I just did a git clone, right? Really simple. I have all the code, right? So if one thing that's beautiful about Docker is that it also works with a tool called Docker Compose, and Docker Compose is going to have your entire local dev environment with all its dependencies all in one place that you can just have. So if I were to build my application, all I have to do is do a Docker Compose build. And what this is going to do, actually before I actually go build it, let's just show you what this Docker Compose file looks like. So here I have two services. One of them is the web, and this is my web application. And I want to build the local directory. So what Docker Compose is going to do is just run a Docker build on this local environment. I'm going to have my application exposed on externally on port 8000. And it's going to depend on my database container, which is the container I have from a local dev environment. Right? So I'm just going to put build. So here I build fairly quick, very simple application, nothing too intense there. So here you can see all the steps of it actually building the web app, right? So to get this environment up and running, I'll put Docker Compose up. And what this is going to do is going to start up all the containers mentioned in my Docker Compose file. And here I can see that SQL Server is running, right? So SQL Server is up. Now I'm going to start my web application. So if we go back to my browser, right? Give it a moment here. I can see my application running. So this is very beautiful in the sense that if I, as a developer, all I really have to do is run 3 commands, right? I'm going to do a git clone, Docker Compose build, and Docker Compose up, and I have my complete environment running, my local dev environment running end to end, right?
And you can still connect to that SQL Server that's part of this deployment with your Operations Studio locally and do all of your experimentation locally. And if you do something wrong, just pull down another copy of it, right? You can throw it away. Or if you find that you do want to deploy it, then that's something that you do have locally that you can do something with.
Sounds good. And to delete these containers, because you don't want to keep, so just to delete these containers so that next time you could rebuild and redo that process. Let's say you make a code change and you want to reduce locally. All you have to do is a Docker Compose down. And that's going to remove these containers and all the associated files used when you build your local environment.
And if you think about, oh, I had a question here.
So in that context, where does your schema come from? Because you're grabbing the default MS SQL container.
So the question is, in that context, where does the schema come from? So do you want to speak to that?
So you can build other containers using the SQL Server container. So in this case, I use the default container. So there's a few ways you could populate the schema. One way is that we populate it from the app. So in my app code, once it starts up, I want you to run a quick migration, and then I have my database populated with my schema. And probably you would like to populate some test data as well, right? Another way to do it is to have the schema already completed in a custom image, in a custom SQL Server container that you have built, right? So there's multiple ways. It depends on it's probably likely a combination of both, where you grab from your production environment the current latest stable, and then as a developer, you're going to apply additional migrations to it just to get the latest changes in which your code represents.
One of the things that I've been talking to some people about lately is that, a lot of these demos show using the public Docker image. That's probably not the way you would do it in your environment, because even though right now we don't have a whole lot of different versions of SQL Server that support Docker containers, as time goes by, you're going to have certain golden images that your security team, et cetera, has said, this is the service pack that we've approved for use, et cetera. And so you'll probably have something like a golden image that has all of the settings, all of the configurations, all of your compliance considerations already baked into that configuration, and it's just not taking the default. And so you'd probably be pulling from that image. And then, do you have more on here?
Nope.
Okay. To me, the difference between a good question is a great question is that a good question we cover later, and a great question is one that's on literally the next slide. So, so it's a really good point. Whenever you're talking about continuous integration and continuous deployment in a data perspective, it brings some different things, because things aren't immutable. And you do have schemas, and you do have data that persists. And in a lot of cases, an application and the whole value of your organization might kind of be a shim of operations on top of very valuable data. And that data is something that you have to curate and protect. And a lot of times you have a different requirements for that in production versus pre-production versus development. So if you think about your environment in a CI/CD perspective, you've got these kind of different environments. You've got various, you've got production, various pre-production, and various development environments. And the production data might not be the same data as you want to use in the development environment. You might need to sanitize it. You might need to reduce it. You can't necessarily bring 20 terabytes down for the developer, and you can't necessarily bring down personal information either. So what we just kind of covered was, it's not really this everything's a 1.0 pushing out. A lot of times you have this flow back from production and back into development, and then back from development to production. So when you're creating these dev test environments, like we just demonstrated, odds are there's a sanitization process in that says, let's create the images from the production data in a pre-production context that our developers can pull down. And then the developers are able to consume that and then make their changes. So whenever they're making their changes and doing local work, they're working on that sanitized data. They're working on that reduced data set. Maybe it's a somewhat contrived data. And then they move out to scheduled tests. Now they're ready to start pushing it out into a continuous integration testing environment. So whenever it moves into your pre-production, now you've got some other operations going on to say, we're going to create a pre-prod environment that's coming from that sanitized data, but maybe it's now going to attach to a little bit more representative sample. Or maybe it's going to attach to a number of different data sets that you've contrived to test certain environments in certain situations. Then from there, you're doing pre-production tests, and then part of that will probably be during the continuous deployment process. All right, we're going to take this as part of production now. We're going to update our pre-production tests to reflect this new change. So now next time somebody pulls down an image, it's actually going to have whatever changes I've made. So let's say I added a table. Now I want to update all the images that the next developer is going to pull down so that it has those images. And then it gets deployed back out to production, and the process continues. So a lot of this stuff with containers, you get the capability of having these branching and kind of forking data environments that has been really difficult to do whenever you were treating these as monolithic individual environments. If you think about how hard it would be using VMs to say, I'm going to have 700 different test sets of data, it's just so much difficulty. And in fact, this is so handy that SQL Server runs its own tests in this way on the SQL Server team. So with the SQL Server on Linux, we use automated testing, and we use Kubernetes in Azure VMs to do the automated testing. The build process creates the containers. It's 700 containers per test run. And you think about what that would be in terms of VMs. That's stacked onto 150 VM hosts. So think how much less costly that is versus actually trying to have 700 virtual machines that you're trying to maintain. We're doing this in Azure. This is something you would also be able to do on-prem on your own virtual machines and your own hardware. And so you can stack them really densely. What we do is we have the SQL Server containers listed on different ports stacked up really densely on individual nodes. And so you can have like 20 containers per VM running these tests. And it's just an incredibly dense suite. And then the product itself is being tested in this way. So SQL Server uses containerized SQL servers to test SQL Server.
This is really nice because when we bought SQL Server on Linux, not only were our customers excited, but our own engineering team was excited because it's like, oh, I actually have to do all these updates to all these VMs in our test lab infrastructure. Well, you don't have to do that in the containerized environment because you only have to update the underlying host that's supporting these VMs, right? And it's actually saving our internal team a lot of money and time. Because this is a very quick way to get disposable containers up, testing the latest build of SQL Server itself, and then discarding it.
Mm-hmm. Now, one of the big things that comes up as being special for the database world versus kind of the containerized application development world is how do you handle schema changes? So data changes, a lot of times data changes are ultimately something that's done by the app. But when you have schema changes where you're saying, I need to add a column, I need to add data masking, I need to make some sort of change to the way that my data is structured, that's something that you're basically using an ephemeral container to make a permanent change. And that's something that can be a little hard to wrap your head around. So the state of the art is still emerging on this, to be frank. People are still learning this. Tooling is still being developed, value adds are being developed, practices are being developed. So these are some of the different options that we've been hearing about for the ways that people are doing this. And I think that you should test it and see what meets your criteria in terms of how often are you doing schema changes, how are they being created. So running DDL directly is still an option in a containerized environment. So if you have a process right now where you have like a change order that goes into a DBA, and the DBA literally connects SSMS to a SQL Server and runs it, and that's still possible to do. You still have SQL servers that have endpoints that you can connect to, and you can do it in that way. We don't think that that's necessarily as flexible in terms of automation, but it's absolutely still possible if you're kind of stepping your way there. Running DDL as a job is probably a little more flexible. So in something like Kubernetes, you can set up jobs and say, just run this and then exit. And so you can set up scripts and bash scripts to say, let's just run this DDL change, and you can do it now in production, and you can do it in pre-production. There's also this notion of having a database container that updates its own schema on deploy. So let's say you have the new SQL Server container that has the engine, and in that container you've packed in an entry point command to say, let's update myself when as soon as I come up, run this script, and then proceed. So that's what you might want to do if you wanted to have a real blocking change. Like, I want to take down SQL Server, bring it back up, and no one can connect until this is finished happening. So maybe like an actual version upgrade. And then app containers updating the schema on deploy is something like if you're using Entity Framework where there's an ORM or something like that that is able to, from code, update itself, then you really just put all of that logic into your app container, and when you update the app code, it will connect to that persisted storage and update its own schema. In that case, you don't probably take any downtime. The SQL Server stays up. That engine, that container hasn't had any changes whatsoever. But the state of the art is still being refined on this. So I'd say, watch this space, try and see what works for you. Just like virtual machines, at first it was like you never run production workloads on virtual machines. You should only be running test workloads. And now everything's virtualized, right? Except maybe the 5–10% of really highly critical, hardware-dependent workloads. And so containers are in the same place that virtual machines were kind of in the early days. People aren't entirely sure, which can make people a little nervous about how to handle it in production. But there are ways to do it. So let's do a
awesome. So let's get into our next demo. And
actually, we have a little story on it. This is our new developer who we just onboarded.
Yeah.
Well, we've just assigned him his first bug. So we found a bug in the integration group.
Yeah, we found, Vicky, the principal engineer, said, oh, Vin, it looks like we checked in some new tests and we discovered there's a bug in one of our pre-project production environments, and it could be pretty bad. You know what, I'm going to leave this super severe bug to this junior engineer, which he's going to fix, right? Yeah, so given that our production environment and our integration environment, everything's in containers, everything's in Kubernetes, one of the things that we do during our integration testing time is that we actually build out new containers as we merge in the code, and we also build out new deployment scripts. So, Vicky's like, so I asked Vicky, I said, hey, it looks like we're deploying our code, everything's in Kubernetes. I want a local environment that I could also represents what we're deploying, that reflects the true nature of what we're running in production. And I'm like, well, how do I do that? I know Docker, I know Docker Compose, I have my local dev environment, but I want to have on my local environment how SQL Server would be running in Kubernetes as well. And Vicky replies me, to get started, you could just use Minikube. And Minikube is a single node Kubernetes cluster in your local environment that you could use to deploy these Kubernetes deployment files. And as I mentioned, in our integration testing, we also automatically generate these Kubernetes deployment files. Okay, so let's just take a look at that really quick. So I want to be able to replicate the bug, all the entire environment, and how the code and the bug all come together. So this is the Kubernetes deployment file that describes the state of which I have the code and the bug and the test itself. So here I have a few services running in this file. So first I have a deployment that first describes my database, right, and it has a service connected to that data that reflects that database, and it also has a Slacker framework. Slacker is a unit test environment for SQL Server, right? And not only am I packaging the database, I'm also packaging in a container the tests, so which on my local machine, on my dev environment, I could repro this issue, right? And I have, here's my Slacker container, and I have a service that represents that test environment, and I have an application as well. Right, so I'm like, okay, well, so at this point, I'm going to switch. So first, I just switch context to my local Kubernetes environment, which is Minikube. And then I'm going to deploy it. I'm using this side. So I have. Right, so here what I'm doing is I'm just going to apply this environment, which represents where the bug was found, into my local environment. So here I created the deployments, the services that backs that deployment. Now let's just start up that dashboard. Right. Oops.
What is it, never type in a demo?
No. Should just be copying and pasting. But anyways. So here I have my Kubernetes dashboard on my local machine. And I can see, so if I go over to my deployments, oh, it's not showing anything.
Your namespace.
Oh, right. So here I created a namespace for this one bug. All right, and I called it SQL DevOps, and this is the namespace which as a developer I could repro this issue. So I can see here I created a SQL Server container, a test container, and my web app. Right. So if I go over to my services, I can see that all these containers are exposed internally, right? So let's go over to take a look at our tests to see where the issue is. So here I have this is the test dashboard here for Slacker. So I'm going to open the output of these tests to see which tests failed.
This is where running on local is a little bit slower than running on your deployed Azure Kubernetes. Slacker, it's an open source project?
Correct, it is.
Yeah.
Right. So the reason why it's a little slow, I'm running this locally in a VM that has maybe too few resources. Let's give it a moment here. Great, awesome. So let's not look at the test that passed because that's not really interesting. Let's look at the test that failed. So here I am. I have SQL Server. I mean, the error itself is not really relevant. Here it's just that I was able to get tests run against my SQL Server all locally in my environment. And I discovered some issues. So let's say at some time later, so I also mentioned that we can connect to this local, this instance as well. So here I could look. Oh, that's not the one. Nope, not that one either. So here I found some tests that failed. Let's go back to my deployments. Now let's say at some time later I found a fix. All right, amazing. I was able to fix this very critical bug in 30 seconds.
Good job,
right.
new developer.
Thanks. So I'm gonna go back to my services, and I can see that SQL Server is running on this port, right? And this IP address represents the IP in which that node is. So I'm going to be using this port over here with this IP address to connect to it locally, right? So I'll have a new connection. Oh, let's just copy and paste this. Right. And my IP address. So this is connected to my SQL Server running in Minikube. Wait, if I remember the password to this. Whoops. Uh-oh.
It's in the YAML, isn't it?
No, I have this as a secret.
Oh.
OK, well, I'm not able to connect to it, but that's OK. Let me just show you the SQL script that I would have ran, right? So let's say sometime I come up with a fix, and I have the SQL file that I want to deploy to my production environment. Now I mentioned in Kubernetes environment, sometimes you may not. So let's say in my local environment, I did just connect using SQL Ops Studio, and I applied the SQL file. OK, great. But in a production environment, I might not be able to just connect to it and just apply the SQL file and just run this DDL, because typically I wouldn't be exposing my database out in the public, right? So what options do I have that I can do in which I can deploy the SQL file, right? So one of the options that Vicky mentioned in the slides, I'm not going to bring it back up, was that you could deploy the schema change in a container through a job, right? So what this container does is it just spins itself up, applies the schema change, and spins itself down. So by spinning that container up in this cluster, it is able to access the resources, the SQL Server in that same resource, right? So let's just take a look at that really quick. So look at the jobs. So let's say I have this bug fix, right? I have this bug fix that I want to deploy. What I'm going to do is I'm going to wrap this bug fix in a shell script, which is going to deploy this into production. So I want to take a moment. So here you can see that the command that I want to run is Flyway. Who here has heard of Flyway? Awesome. So if you think about how you manage, so one of the things that we were talking about just earlier at the very beginning was managing your schema, right? Managing your schema like you should manage your schema like you would manage your dependencies. So often, when you think of an application, you think of, oh, I have one app, I have one database. Great. What could go wrong? But typically, in a real-world environment, you have multiple environments. You have test, you have integration, you have pre-prod and prod. So if you have, typically, when you deploy the code, people have a very good understanding of code versioning. You're like, I know which app is running out there. But when you ask folks about, hey, what version of your database are you running in terms of code and it supports the app, people are like, I don't know, I applied some, I know that the current state of this database supports this version of the app.
Or they're like, they version it by backup files. I took a copy of it,
Yeah, so Flyway, what it does is it manages the schema, manages the schema migrations. So I'm just going to do a really quick demo here just to demonstrate that. So I already have the configuration of my environment here. So I'm going to run Flyway info, which connects to my environment and it's going to just grab the version. So Flyway is a great tool in which you could just deploy .SQL files against your database, and it's going to grab the version of it that it is. So currently I'm on version 1. I'm about to deploy a fix to it. So here it just says baseline. So you can introduce Flyway into your environment at any time, but just running a baseline saying like, hey, this is my current state. From this point on, I want to be using Flyway to manage my schema. This is really great for that in that sense. Awesome. So now let's describe what Flyway is. So I have a YAML file here. So I said this is going to be a container, and I want to deploy it to my Kubernetes environment. And here it's just going to say, hey, I want to run this shell script, which then calls Flyway, right? So this Docker file is nothing interesting. So let's just go ahead and let's go apply this fix immediately. So oops, wrong folder. Awesome. Yep. So here I specified a job which I want to run in my environment. So if I go to my dashboard, my Kubernetes dashboard, so I'll go back here, and I'll go back to my normal namespace. I can see that I have a job running against. This is not. Whoops. This.
I think you were running on prod rather than.
Huh?
Were you trying to run it on your minikube?
Oh, did I switch environments? So let me just take a look at my. So I applied this to my local dev environment, not production. So let me just switch over to my production environment really quick. Well, not my production environment, but my pre-prod environment. OK. So let's just kill this. And let's apply it again. I have much to learn from our principal engineer, right? Making silly mistakes like this. All right. Whoops. So let's just go here. Look at this. Oh, I didn't run the actual web app that actually connects to my cluster. So here, I'll run it. All right. Now we're here. So here I just applied this job to my database that's running in production, right? So if I just take a look at the console, I can see that here I applied a bug fix, a fixed bug. So it's that version, schema version 1.1, right? And that's how we deploy a schema change to our SQL Server, because we can't just deploy a new container. One of the things that you would like to minimize your downtime, really, because if you were to swap with the container or do another large operation, you could bring downtime to your application.
It's also certainly the possibility that you're running in an environment where your SQL Server is running lots of different database files. And so this change, if it's only affecting one of the databases, maybe you don't want to bring down your whole SQL Server for the sake of making that one change. That's kind of the situation you would have in one of those other environments where you said, I'm going to push a new SQL Server that was going to upgrade itself. But let's say you did have a security fix or something like that you did want to block and say, hey, we're taking an outage in order to get this working, then that might be a different way. So honestly, I had said earlier that you might want to find what's the best for you. It might also be something that you want to make a playbook for what type of deployment works for the different types of updates you're doing. There's something going to be very different for basically a typo situation and you just need to do a quick fix versus something that's maybe a long planned version upgrade, et cetera. And just like anything else, you can choose to say, is this a continuous thing? Is it something that's literally going to go in as soon as somebody's checked it in through VSTS? Or is this something that's going to have a gating process and we choose we're going to do this at this maintenance window?
Yep. So one of the things I also like to show you from the very beginning, remember we just killed that pod, it's back up and running. So there you go. That works as is. So let's just do one last check. I was going to kill this. And I want to take a look at, again, I want to reconnect to my pre-prod environment and just take a look at what Flyway has deployed. Right. So here I can see that I did indeed version my database up one more version to 1.1, which includes that bug fix that Vicky told me to go fix.
Mm-hmm. And then if you wanted to rerun those tests, all you'd have to do really is kill that Slacker pod, right?
Yeah, yeah. So one of the things that I showed the test I had, let's say I fixed it, let's say I fixed it and I applied it, because I have my Slacker pod at start time, it just runs the test. One really quick hack I could do is, yes, I could find a way to restart the test the way that Slacker has it for me, or I could just kill the pod. If I kill the pod, Kubernetes is going to try to have its desirable state, which is to have at least that one pod. So it's going to spin it back up. And at start time, it's going to rerun its tests against my local dev environment.
Honestly, I think there's something a little bit fun about when you're running in Kubernetes, and it's basically like the way to get things to work is just to push it over. You just just kill it, and it'll start working again. It feels kind of, I don't know, it's exciting and fun.
Sounds good.
So
great.
So that is the end of our formal demo portion, and so we wanted to leave lots of time for questions and discussion because we know that this is an area that's that's new to a lot of people. I do want to say that we do feel that containers are going to go the way of VMs, and in the SQL Server team, we're going to try to make that as easy and seamless a process as possible. I think that a lot of people were kind of taken by surprise by VMs. They kind of came up. It was something that they didn't have to pay attention to, and then suddenly it was something they had to know about, and the tooling had to catch up with it. There were a lot of weird practices and best practices around. Are we going?
I'm just go back to just bring up one point about what you mentioned here. Oh, this is so far back. Wow, so far back. So I just want to bring up this about integrating what Vicky mentioned, just to reinforce what she said. SQL Server in your database goes into so many environments. We just showed a few a few ways that you could greatly simplify your environment. Whether it's dev or test or even production, right? So if you start looking at, hey, how can I start simplifying this stateful service that I depend on as a developer? I would really just start with the local dev environment, right? Mm-hmm. Instead of having to ask someone else on, hey, how do I spin up a SQL Server? To start with containers. It's
yeah, and that's actually a good point, because if you think about it, the entry point for virtual machines into a lot of environments was for the developer experience to say, all right, well, we're still running production on physical hardware, but we're going to have virtualized environments for dev, and then we're going to have virtualized environments for test. So you don't necessarily have to do this all at once. This is still, even a containerized SQL Server, it is still SQL Server. It is still the retail version of SQL Server. So anything that you have running to make your local dev environment easier, you could still be running it on Windows on your existing hardware in production, and you just need to push it to it using the more traditional fashions that you're already familiar with. But you can probably take it back and improve your developer onboarding experience right away. You could even just say, look, I haven't got the entire app story, I haven't got the entire CI/CD down, but what I can get down is everybody, you're going to start using Docker to pull down a local version of your SQL Server, and it's going to have the representative data sets. And that's it. That's the only thing that you're running locally on a container. And then you can kind of move your way up from that.
Cool. Yep.
All right, have a question?
How does licensing work with containers?
So the question is, how does licensing work with containers? And so I'm gonna pull please let's talk about it after, because I don't want to give anybody bad advice. Fundamentally, there are some special situations for just like virtual machines, for how you handle containers. It is still a commercial product, but for developer purposes, that's another thing. If you're using Developer Edition, you don't necessarily have to worry about that quite as early on in the process. But yes, let's please be in touch after to have more specific questions. I have a question here.
So what you just talked about, the developer onboarding, that sounds ideal. Devs, there's some launches, some are comfortable. Given that we have Windows, SQL Server, shared dev environment, how do I migrate a container from my Windows database?
So the question is how, wanting to move to a local dev environment like we demonstrated, and they already have a shared dev environment, how do they hydrate a container to create that local and dev environment? And so that's just the process of, I don't want to put you on the spot to try to do it or anything, but you just create a new container.
Yeah, so everything I showed here today was on Linux and Mac. We also have Windows containers as well. So the way we would do it is have a base. So you create a new Docker file. The way you do it is you start from the parent file you would have is the SQL Server, the official image that we have. And to build on top of it, you potentially have the MDF and LDF files that you want to attach to, or you create a backup and you put it into the folder, right? So you have the current state and you bring that into the container, right? And at start time, you do a restore. So then at every single time when the container is spinning up, you're going to do a restore of the state in which you want it to have, right? So you can imagine if you have one shared environment, now you're going to just take all those, you can take the databases that the devs do care about for their own dev environment, put those files into the Docker image, and then have that started. So you abstract it away from that perspective. Then those devs wouldn't be interacting with each other.
And so then what you can do is you keep that image up to date by basically replacing the files that are in it and kind of versioning it. And you can even do it even simpler if you wanted to and say, I still have a semi-shared environment. And you can say that the entry point to this container is actually to go to this network location and get those files in to apply that backup. And that lets you maybe have different backup sets for different test environments or test situations. Maybe somebody wants to have a much smaller version just for quick testing, and then you have kind of like the more performance testing version that has a larger data set, et cetera.
You could imagine in your integration environment, as the database is getting updated, it also generates a Docker file in which the developer can use to generate their own image and customize it to replicate a certain bug from that perspective as well.
Now, I will say, if you're coming out of this, and I hope you are coming out of this excited about that, do remember that the SQL Server will be running versions 2017 on that local dev environment. So if you are not running 2017 in production, it doesn't mean that there's no benefits you can get. You just have to be aware. Like if they're using functionality locally that isn't available in the version that you're running in production, you'll have to adjust for that. You can probably do some of the basic, schema type things. As long as you're actually applying schema as code, it's not going to have a huge effect. But if they start using features that aren't available, even going back to SQL 2016 type features, then that's going to cause a problem. So we had a couple other questions.
Yep.
So, getting back to that, the Windows SQL image is gigantic.
Mm-hmm.
And if you want to do anything useful, I had the same scenario where I created a container that had a whole bunch of MDLs for a dev. And you have to start it up with, you have to do Docker run, and you have to put at least 4 gigs if they want to do more if they want to do anything useful. So, are you doing any sort of performance improvements there to reduce the image
Yes.
cost against
The question is, the SQL Server is enormous and it uses about 4 gig at a minimum. And I'd say we are working on that.
Yeah, we are working on that. So I believe it's 2 gig, the minimum requirement. But I understand what you're saying and how many resources it requires. So one benefit there really is that once you pull down the file, because Docker, when you do Docker pull, it pulls down layers, right? The next time you build a container on top of that image, it's going to be much faster because you're not going to re-pull down those same the file layers that you have. But yes, to answer your question, we are doing some.
It's 10x difference. The Linux one, I think, is a gig. The Windows one, I think, is 9.
So you're talking about the Windows container size?
Yeah.
Yeah, so yes, the Windows containers are going to be a different thing.
Yeah.
I'd say for the dev environment that we're talking about, I would probably go with just the Linux container.
Yeah, so also if you don't need access to any of those Windows functionalities, you could also run Linux containers on Windows, right? So that's also another alternative. But yes, we are finding ways to make improvements on both. Yep.
So if you're using Active Directory to manage security in SQL Server today, how does SQL Server on Linux and containers play into that security model?
Yeah. So the question was, hey, if I'm using AD on Windows today, Active Directory, how does this work with Linux and containers? So on Linux, we do have AD. We do have Active Directory on Linux today. So configuring it is different from Windows, because if you're on Windows, you would just go to your control panel, join your host machine to the 80 domain, and now that your host is joined, SQL Server will have the service principal names all generated at start time. On Linux, you have to manually configure that, because it does involve mangling some bits on the host machine itself. It's not too bad. Now in containers, this is something that we are looking into, because each container is a host on itself. So that is not yet supported. We are working in that space, and stay tuned for that.
Right, so that was the next question, is if you're doing auto-scaling of SQL Server clients, how do you get those Linux-based clients to authenticate to SQL Server? And are you planning to implement any sort of cert-based authentication that would allow us to auto-scale clients without being on the domain?
So the question was, how do you use cert-based, right? So that's something that we're working on. That's something that we're looking into. Yeah.
Yeah, so we are going all in on containers, and so the security and authentication methods is something that's really very much in the crosshairs.
Yeah.
It's not going to be very coherent for us to tell people, best practice is use 80 authentication and then not support it, our new initiatives.
So for 2017, if you look at the difference, just as a blanket statement, the difference. So I often get the question, hey, what's the difference between SQL Server running on Linux and containers versus running on a Windows? If you're running it on the engine isolation that doesn't revolve any other components, it is the same engine. So all those T-SQL capabilities that you can access are the same, right? Now, if you involve other components that are external, such as replication, which has different other components, those are areas that we are working on lighting up for the next version of SQL Server as well. Yep.
So you guys are saying that containers are small and lightweight. In our organization, our SQL servers generally have more cores and more RAM than any of our other boxes. So are there performance implications with migrating to a container strategy?
So the performance situation, once it's up and running and your actual workload is running, you're still going to have to take a look at what your queries need to do their work. So when we're talking about small and lightweight, we're kind of talking about the deployment size and the ability, but it is true, if you have a major production workload and you're running on a lot of cores in order to get massive parallel activity, etc., that doesn't go away. There's nothing about the SQL Server running in a container that's going to make your select statements require fewer disk resources.
It might be faster.
It might be faster.
because we were talking about, remember one of the things that you don't have to do, and the biggest difference between a container environment versus VMs is that you don't have the OS, right? So if you're not spending resources, with
the overhead.
For the overhead of the OS, and that definitely depends on your environment, right? It's not like that statement's gonna be true, but for all environments. For our testing environment, so we were showing that the SQL Server team itself uses containers for testing, right? So we are able to have more density because we're not using the resources that's required for the OS, and we're redirecting it to have more density for our SQL Server in our test environment. Right?
Are there mechanisms within the orchestrations that allow you to control like how big you want these things, or how beefy you want them to be?
Yes. So there's different configurations in Kubernetes and container orchestrations that allow you to control the resources, and in Docker as well. So, yep.
Okay. Thank you.
All right. Let's. Here.
Do you have any tricks for base image upgrades? Like, if I'm going from 17 or 2017 to 2017 SP1, and I want to kind of minimize the downtime, is there like a way to quickly attach with hot standby containers?
Yeah. So I think the question is there any tricks for I want to upgrade the version? I'd say probably you see if we agree on this. I'd say that you probably cleanly shut down the SQL Server and then bring up the other one, because we've been talking about killing it, but then you're going to be going through crash recovery. So if you just say shut down and then bring it then create the new container, that's probably what you actually want to have happen. It's kind of exciting to see a demo where somebody kills it, but then you do have transactions that are in flight, etc.
Correct.
If you're able to take the extra 2 minutes to allow transactions to complete and quiesce, then it's going to be faster.
So these demos are great for like the local dev environment, maybe even like dev or QA, but like realistically in production, I have a web farm with n instances of my applications and services all hitting a SQL cluster. So then what's sort of the analog of that? Like how would I migrate from having a SQL cluster to going into?
So it depends in part on what type of cluster you're dealing with. If you're dealing with a failover cluster, then in a sense, going to Kubernetes it's still a failover cluster. You still have the capability of basically if the engine goes down, it's connected to shared storage and comes up. If you're talking about something like high availability, always on, that is coming. So that's again one of those external features like replication that is being fleshed out, working very explicitly on it right now. And so in those kind of scale out, read intent, et cetera, that is on its way.
Yeah.
And you've been waiting, I'm sorry.
So can you use the service fabric as an orchestrator for this SQL Server container?
That's a great question. So the question was, can we use Service Fabric as the orchestrator for our SQL Server containers? Today, I believe, so I don't work on this, we haven't looked into that one, but this is something that we are looking for in the future as well. So it's not just about getting, it's not just about getting the container running, right? So one of the things that we are looking at is operationalizing aspects of running containers in production, which means what's our HA story? So notice how when I just killed my container before in my Kubernetes environment, it didn't spin up right away. Now, it had about 5 minutes of downtime. That's in a lot of critical workloads, that's not acceptable, right? So you do need always on, or you need to have multiple machines where it could fail over extremely quickly, right? So it's not just about, hey, can I run it? It's, can I have this running reliably in a production environment? And that's something that we are still looking into for other orchestration platforms. But we would love to talk to you afterwards about Service Fabric if that's something that you're interested in.
And can you have an integration with the DAC pack?
So
Can you have an integration with the DAC pack? So SQL package for cross-platform is going into preview any day now. So in that case, your DAC packs are going to be able to be brought forward.
And DAC packs would actually fit very beautifully in this, because you can mention it as a job, you just deploy it up, it runs the DAC pack. And for those of you who are not familiar with DAC packs and SQL Packages is this beautiful tool in which you can define a model of SQL Server in which its desired state. And all you have to do is run this DAC pack, point this at the instance the database you want to upgrade, and it will automatically generate all the SQL scripts to get you from point A to point B. But, yeah.
One more question. Like you mentioned in one of the presentations saying that like we have a 3-node this cluster,
Yep.
and in which like you elected one of the nodes to be accurate all the time. So now like what happens? Like we have a shared storage
Yep.
where we have a mounting, everything is happening. But if you wanted to run 2 nodes in our scenario, like the 2 nodes will be accessing the data from the shared location, same shared location, because like we saw that in other
Yep.
things that like you cannot have a more than one shared
Yep.
pointing or something like that. How it would be?
So I think what you're describing is a
Oh,
multi-write. Whoops. I just wanted to get to the remember, do provide us feedback. So I'll get to that last slide before the remaining of you head off to your next session. So that's going to cause problems. It's the same as if you were to have a shared storage and you have 2 SQL Server instances pointed at that shared storage. You're going to run into the same set of issues where you're going to have a collision. So that's not going to support it. Correct. So you can't. So unlike web apps, you can't just scale it horizontally, right? Where you're going to have multiple database instances.
And what happens with the SSIS and SSRS when you have it in the SQL Server as a container?
So your question is SSRS and SSIS coming to containers? So SSIS is on SQL Server on Linux today. So I do not believe they have a container image up. That's something that, but that's something that could be built fairly easily. If you wanted to build your own Docker image with SSIS. SSRS is something that is not on the roadmap yet. It's not on the roadmap yet, but that's definitely feedback for us to bring back to our team.
So we're actually out of time. We will still be here for questions, but we want to make room for the next presenters. Please do complete your evaluation form. This is really important. Helps us to understand what went well, what didn't, and build better for next year. So thank you all so much for coming so early.
Have a great last day.
Thank you.